Hi everybody, and welcome to example 3 on page 56 of the workbook. And in this video, we will be working through parts A and B of this example. This is an opportunity to try out some of these new derivative formulas that we came up on the previous pages. All right, so let's start with part A here. So it would like us to find the derivative of the function y equals ln of sine of x cubed. Okay, so just like we did in the last section, we want to look at that function and decide what kind of a structure does it have? Where do we want to start on this problem? And you might notice in this case that we've got an inside and an outside function. You can think of this ln of sine of x as being inside of the cube function, so this is a typical chain rule situation that we're looking at. So to find dy dx, we are really trying to take the derivative of u cubed. U cubed is our whole function. And so how do you take the derivative of u cubed? Well, that's going to be a power rule. You're just going to get 3u squared. And in our case, u is ln of sine of x. So we're going to get 3 ln of sine of x squared. And the second piece of the chain rule says we need to multiply by the derivative of just the u, the inside part. Okay, so there's our first step, and we are done with the 3 ln of sine of x squared part. Okay. To finish, we need to take the derivative of ln of sine of x. Okay, what kind of a derivative do you see there? Okay, well, notice that we've got another inside and an outside function. This time, the inside function is sine of x. That's our u. So we are trying to take the derivative of ln of u. That's our whole function. What was the derivative of the natural log function again? Let's sneak a peek. Okay, so natural log derivative formula was the one right here. So its derivative should be 1 over x if we were just taking the derivative of ln of x, but we're taking the derivative of ln of u, okay, where u is this. So we're going to get 1 over u, which is 1 over sine of x for that. And then again, the second piece of the chain rule is to take the derivative of the u. Okay, and let's see. Looks like we are done with a few pieces here. So we've got 3 ln of sine of x squared, done with that. 1 over sine of x, we're done with that. And finally, we need to take the derivative of sine of x. That's just cosine of x. All right, and so this would qualify as a final answer. If we wanted to, we could simplify this a little bit. Okay, so I'm going to give you a couple of alternate ways of writing this. We could also take these two pieces here and maybe consolidate them together into one fraction. Okay, as cosine of x over sine of x. That would also be an acceptable way of writing this. Or you could even, if you've recently taken a trig course, you might remember that cosine of x over sine of x is equivalent to cotangent of x. Okay, so we could even write it like that if we wanted to. All right, and I want to emphasize that any one of these three answers that I circled would be fine as far as giving it as your final answer here. Okay, well, let's take a look at part B then. Okay, so there they'd like us to take the derivative of y equals arc sine of the square root of x times the natural log of x. So what do you see when you look at that function? Okay, how are the pieces being combined together? Well, notice that we've got a product going on. Arc sine of the square root of x times ln of x. So we're going to need to start with the product rule. All right, so the derivative in that case is going to look like, let's see, the product rule says first function times the derivative of the second function plus the second function times the derivative of the first. Okay, so there's the first step from the product rule. And to finish, we need to take these derivatives that I'm underlining. All right, so let's see, we'll rewrite the arc sine of the square root of x part. And then what was the derivative of the natural log of x again? That's just 1 over x. This time there's no chain rule, so we're just going to get 1 over x. And moving along, we've got the natural log of x, and then we come to the derivative of arcsine of the square root of x. Notice that that's a chain rule situation. Okay, our u is the square root of x. So first thing we need to ask ourselves is, how do we take the derivative of our whole function, arcsine of u? Okay, well, let's sneak a peek. So formula for the derivative of arcsine of x is sitting here. It's 1 over the square root of 1 minus x squared. So in our case, we're going to get 1 over the square root of 1 minus u squared. Okay, so 1 over the square root of 1 minus, there's our u squared. And then the second part of the chain rule is to multiply by the derivative of the u. Derivative of the square root of x, I'm going to write the square root of x as x to the 1/2. Okay, and most of the problem is done at this point. We need to rewrite the parts that we've already completed. Okay, 1 over the square root of 1 minus, and then we come to the square root of x squared. We might as well write that as just x, because when you square the square root, you just get x. And then finally, the derivative of x to the 1/2 by the power rule is 1/2 x to the negative 1/2. Okay, and there is our answer.